Welcome. Let's have a look at Bridge Repair Day 7 of Advent of Code 2024. For this first part, they want us to figure out if or determine if these two values on the right can somehow yield the value on the left. And we're allowed to place an operation between these two numbers or any pair of numbers. Um, the allowable operations are either add or multiply. So again, in this case here, they want to know if we were to place a plus or multiply between either of these, four there's four possibilities, right? Plus plus, times times, times plus, or plus times. They want to know if either of those four possibilities will yield the value 3267. One thing to keep in mind is that they allow or they require that the values are or the I don't know what the term is, but operators are always valued left to right, not according to precedence rules. So even though we can put a plus here between the 81 and 40, um, and the multiplication between 40 times 27, we would still add 81 and 40 before we multiply the 40 and 27. Again, because of this requirement that they state. Okay, so that's basically, well, sorry. And then what they want us to do is, of the rows that are capable of being correct, um, we have to add these values and return that. So for this first example, what does it say? I think the first three equations were correct, and they add up to 3749. Okay, so let's see how we'll do it. So what I first I'll go over the algorithm. Well, actually, let's go over how I open the data. So here's the data here, and sorry, this is do test. So the data looks something like this. We're given this target value separated by a colon, and then space, and then the possible values, the elements that are available to us. And then we can insert either a plus or multiplication operator between every pair of numbers or elements. So what I did was I stripped the new line and I replaced the colon with an empty space. So essentially, I'm left with something like this. And then notice how every element is separated by a space. So then I split this. This is a string. So I split the string on a space. So then at this point, this is a list of string integers. But we want to be able to interact with these elements as integers. So I run the map function and I apply every element in that list of strings. I convert it to an integer and I make a list out of it. And then I append it to E. E stands for equations. Okay. Then I loop through each equation and I parse the first value because that'll be our target, what we're aiming for. And these will be the elements that we can use to somehow aggregate to this target element. And I'll go over the function in a moment, but if it returns true, I add that target to our total, and then I just print the total at the end. So let's go over what's the thinking for it, because I think it's very important how we do it. So my idea is to strip off one element at a time and then move forward. So the goal is to reduce this down to maybe even one element or zero elements and a target. Before I get started though, since we'll be using recursion, I want to go over an important piece of info, or what's the word? Something we need to consider. Yeah, something important that we need to consider. So remember the goal is to, or the idea is to remove elements from the right until there are either, the question is, do we want to stop at one element or even no elements? So let's suppose we stop at one element. If we stop at one element and we're at this and we're here, all we need to do is check if we have a one element remaining, we just check if that element equals the target. So again, if we have this target and we have this number, and remember this on the right side would be the possible listing of elements available for us to aggregate to 10. If we have one element remaining, I think it would be simple if we just check if that element equals the target. That's one possible base case. So again, this is one base case, one element remaining. Now let's try another scenario. What if we want to use the base case where there's 0 elements remaining? 0 elements remaining. So, well, let's think about it. If we were at this point, 10, 10, and we strip it off, let's strip it off. So, well, remember, we can strip off by, we're allowed to add and multiply. But if we're stripping off elements, we would be stripping off either by subtraction or division. So let's suppose we subtracted it. Let's subtraction. So if I subtract 10 from, so in essence, I'm removing this element so that no longer exists. However, for this target that we're concerned with, 10 minus 10 would be 0. So we'd have 0 as the target, and then we have like no elements remaining. Okay, that would be one scenario. Otherwise, the other stripping off or inverse operation for multiplication would be division. So if we did perform division here, so again, we're stripping off the elements. So there would be no more elements on the right to strip off. Now, 10 divided by 10 is 1. So we have either of these base cases. So if we have 0 elements remaining, either there will be, well, no elements always on the right, but there could be two possibilities on the left. There could be a 0 here or a 1. So I am just exploring this so that we get a thorough understanding of what base case we want to use. We can use either of these, but I think this is probably maybe cleaner because we don't have to deal with the two issues. So we can I'll just point out what I did here. So that's exactly what we did here. So I called this helper, and this target was at 10 and elements, and I check if the length of elements equals 1. I return if that target equals the elements. And if they're equal, it's true. If it's not, then it's false. So I wanted to point that out. Next, moving on. So let's go over this example here. So remember, the idea was to strip off elements. So these are our possible candidate elements, and we need to somehow insert either plus or multiplication operators to aggregate to 24. So then there are two thoughts. Sorry, let me point this out to you again. operators are always evaluated from left to right. So let's make that, I want to make that clear. I want to restate that so it's fresh in our mind. So going back to the question becomes, do we want to strip off elements from the left, so this 5, or do we want to strip off elements from the right? So suppose we had decided to strip off elements from the left. Strip off elements from left. So left to right, left to right. So we would strip off 5 first, then 3, then 9. So the question becomes, we don't know if it's 5 plus then whatever other elements, or we don't know if it's 5 times the other elements. We don't know. So if we did have 5 plus the other elements, well, to strip it off, we'd have to subtract 5. So one thing that we'll check for when we strip off a number is that we want to make sure that this number is less than the target. So we need to ensure that the element that we're focused on is less than the target. So we'll just call this target on the left. Target and elements, just for clarity. Cool. And then, so that's one thing. Before we can strip off for a plus, we need to ensure that the element is less than target. Okay, and then we would move on to something like this. So we'd have 19 now, and the new elements left remaining would be 3 and 9. Okay, over here, suppose there was a multiplication operator between them. So, well, in order for us to strip it off, we need to make sure that this number, this target, is divisible by 5. So we need to ensure that the target mod the element that we're concerned with. So this is the candidate we're trying to strip off, element equals 0. And suppose that it is, or actually, so we need to ensure that, yeah, so if it was, we could move forward. But notice in this case, 24 is not divisible by 5. So then we could not move forward. Could not move forward. Because this isn't true. If it was true, just suppose it was 25, it would be, we would do something like 24 divided by 5, and then move forward with 3 and 9. If it was true, we could move, if true, then we would have the problem would look like this, but it isn't. So that means we have to, we would stop going this route, and then we would continue with this 19. So for the 19, I don't know if it's, so again, we're looking at stripping off from the left. So if we strip off 3, we ask ourselves, so this is for addition, and this is for multiplication. So if I strip off 3, again, we have to ensure that 3, we're going to subtract it so that the target is bigger than 3. And yes, it is, so it would be, 16? And we're left with 9. Over here, we would have to ensure that 19 is divisible by 3. So ensure 19 is divisible by 3. But it isn't. So so we would stop. If it was, we would continue. We would have 16 divided by 3, and then the remaining element would be 9. And then, as you can see, they're not equal. So looking at all the possible branches, so these were all the possibilities. Notice how we didn't arrive to an answer. So does that lead us to conclude that there was no answer, or it isn't possible to aggregate these elements to get to 24? Well, no, I mean, because 5 times 3 is 15, 15 plus 9 is 24. But what we're saying is, with this approach from left to right, it would be somewhat more challenging, and we'd have to add some complexity to it to make this work. Now let's try stripping off elements from right to left. So what are we at here? So let me just copy this down and do this here. And now this is from strip off elements from right to left. Okay. So in this case, all right, cool. So we don't know, we have two options here. We don't know if it's 24 is, so here's 5, so other elements times 9. We don't know if that's true, or if it was 24 is other elements plus 9. We don't know, as we didn't know over here. So for the multiply by 9, as before, if 9 times something equals 24, both sides need to be divisible by 9. So ensure target is divisible by element, which happens to be 9 in this case. If it is divisible, then we actually divide it, and then we move on to we carry on with the same process. In this case, it isn't, right? 24 is not divisible by 9. Otherwise, we'll consider this plus operation. So we ensure now that the target is bigger than the current element, which happens to be 9. And yes, it is. 24 is bigger than 9. So we would move on. We'd continue on. So we continue on with 24 minus 9. That would be our new target, and our remaining elements. The other elements happen to be, what are they? What is it? 5 and 3, which happen to be 5 and 3. So in this particular case, it would be 15, and 5 and 3. So then we have two options now, right? We don't know if it was 15 and if it was 5 plus 3, or we don't know if it was 15 or 5 times 3. So remember, we agreed that well, maybe did not. I erased it, but remember we decided to remove the elements until there's one element remaining. So right now there's 2 elements remaining. So let's reduce another element. So if this is the addition route here, addition and a subtraction. So what we'll do is, remember, we consider if we want to try removing 3. So we always ask ourselves, is the target bigger than that element, which is, in this case, it's we're looking at, is 15 bigger than 3? Yes, it is. So we can look at, so we would get 12 now, because we're undoing it. We're stripping it off. So we're taking off the 3. So now we're left with 12 and 5. And then if we continue on with the base case, this would be the base case, one element as a possibility, and this is the target. And so this would come back as false, or false, because we couldn't, going this route, we couldn't make 15. We couldn't make the original target 24. And the way we reached this was we had a 9 here, right? This was a 9, and then this was another addition. That's the branch we went through on this, and yes, that's true because 5 plus 8 is 5 plus 3 is 8, 8 plus 9 is 17, not equal to 24. So, however, let's try this route. So, not sorry, this is multiplication. Multiply. So we want to undo. We want to strip off this last element. So since we're multiplying, we would divide. So remember, we need to ensure target is evenly divisible by the element. So in this case, 15 mod 3 equals 0. So that's great. That means we can move on. So we're stripping it off. So that means, as far as the right side is concerned, we just remove that element. We don't need it anymore. As far as the left side is concerned, since we've stripped it off, that means we're dividing it. So that means this is 5 here. 15 divided by 3 is 5. And then this goes back to our base case. Our base case said if there's one element remaining, if it equals the target, then that's good. Then we can aggregate the provided elements to get the target. And going down this branch, so this was multiply here, so that means this was multiply here. And then originally, where were we at? We added the 9, so this was a plus here. So that's why we need to strip off elements from the back of the list to the front, from right to left. Okay, I just wanted to make that clear. And then, well, that's basically it. So what we've done here is basically that. So let me just walk through it. So let me walk through this one first. I think that's easier. So this is, notice, ask ourselves, or myself, is the last element less, and this is for subtraction, or I don't know how to, we'll call it addition, maybe inverse addition. And over here, this will be inverse multiply. So remember, the last element, is it less than t, which is like we did over here. Remember we couldn't, we needed to make sure that if we undo this element, that this element is bigger than that. So if that's true, then we move on as we did before. We just subtract that last element, and now we take every element, all the other remaining elements. So this is just shorthand for that. This is just a nice way to say something like, if we add 5, 3, and 9, if we do this, if we have L equals that, and then if we have L to -1, this would equal 5 and 3. It's just a nice, easy way for doing that. So that's what we do. So essentially, this strips off the last element. And then we move forward. And then we keep moving forward until we reach the base case. Here's the inverse multiplication. So remember, we asked ourselves, first thing we need to do is check if the target is even divisible by that element. So we use the modulus operator, and we verify, or we ensure that the target divided by that element, the last element, is 0. If it is, we can move forward. So we divide that target by that element, and again we strip off the last element. Now, if either of these don't work, we just return false. And that's it. Then we can just test it. So what is it? Python problem 7.py. And I think that was the answer. Let's check it. Yes, 3749. Okay, not too bad. For the third problem, for part 2, I don't know where I got that from. They add a new operator. It's called the concatenation operator. So for previously from the first part, we had something like 156, and using addition or multiplication, we could not aggregate these elements to make 156. However, with this new allowable concatenation operator, if we concatenate 15 and 6, yes, we can create 156 from 15 and 6. So let's go over how we'll modify our current setup. Now the goal of this though is to since this works, so we know this works. Our goal should be to try to alter to minimally to minimize the amount of alterations needed for this, because we know it works as it is. In essence, though, we should only need one more inverse concatenation. We should only need one more if statement to accommodate the new operator that we're allowed. So, well, we can do it here. I did have it over here, but I can just walk it through with you. We'll just go over. Let's build it now. So let's look at this here. So what I'm going to do is I'm going to say I'm going to call this last equals. Sorry, let's go over how to do it first. I'm going to delete all this because it's too much comments. All right, so let's go over how we'll do it. So if we have something like that, let's go over so let's just do that one. 156 and it's 15 and 6. Okay, so let's just focus on the concatenation inverse. So, well, what is the concatenation inverse? So we need to say to ourselves, all right, so inverse concatenation inverse. Okay. So what we need to do is I'm going to set last equal to the last elements, and I'm going to set it to the last one. But I'm going to convert it to a string. Convert it to a string. Because since we're going to be removing the last element, it makes, in addition, concatenate. So let's go over that. Suppose though the last suppose we had this here 2, 3, and 6, and maybe even 4. So notice though that if the last element is longer than this one, we can't undo it. We can't strip it because it's too big. So this has 4 elements in it, and remember we want to take one off. Like in this case, it's nice, right? Because, well, why is it nice? Because this has a length of 1, this has a length of 3, so we can undoubtedly remove one character. So when we're doing this, we need to ensure that the length of last is less than and I'm going to put here strictly less than, for now, strictly less than, do this, strictly less than the length of the target. Okay, and to make it easier, we'll just call T, I don't know what to call it. We'll call it S equals converting the target to a string. And we'll get the length of the last. N equals the length of last. So ensure that the length of the last element is strictly less than the target. Yeah, because we can't take off more. Yeah, like I told you, if this had a length of 4, we couldn't undo it. It wouldn't make sense. It would be impossible. And then that would be it. So we need to ensure. Sorry. We first need to ensure that the length of this last element is less than that. But well, let me just change this real quick. Well, then we also need to end. So then we also need to check and ensure that the last element equals so if this is a length of 1, we want this, we want to, how far do we want to go back? So we want to say let me see, equals the back elements or rear elements of S. And the question is how far do we go back? So that's why we need this n here. So we'll perform this check here. It looks something like S of, let me see, what is it? So negative n to the back. And this is just a way of getting, in this case it would be, what is it? S of -1 to the end. And just as a quick, just to point it out, let's call this, let me see, Python. If I had, suppose I have, let's just do it like this. So S equals 156. And we want, remember we want, in this case it was 1 here. So if we want the last element, it would be S of -1, and this should give us a 6. So this is just a quick way of getting that last element. Or we don't know how long it is. So if suppose we wanted 2 of them, then we could get 56. So this is for our convenience. So we would check if this, yeah, ensure this is last. And otherwise, move forward. Just, yeah, move forward. So then we just move on to the next one. So we would say, so we ensured that the last element equals that, so we strip it off. So we want to get, what we want the front of the elements. So we want this part. So once, I probably should let that open. So Python, so once we know that this equals 6, and this is true, I hope, yeah. Then now we're only concerned with the front part now. So we took off the 6, we stripped it off. Now let's do this here. I think it would be something like this. And this is the front part. So then we would move forward with, yeah, this approach. And then now the elements as before, because we've stripped off the last element. And that's it. And then I think I'll go over this. I'll go over this in a moment. Why the strictly listen. Okay, so then let's implement this. So we'll say last equals elements -1, and we'll convert it to a string. And then we'll say we'll get the length of that. Length of last. And then we'll say S equals the string version of target. Okay, so then we want to say okay, so if S is greater than n, so this has to do with the lengths of the string and the last element. And remember, we want to check that the last element is equal to these last elements of the string. So S of, what is it, -n to the end equals last, and then we move forward. So we say helper of, we want the front part, so S of -n here. Now this is the front part of the string. So because we stripped off the back of the string, now we want to move on with the forward part of the front part of the string. And elements, and we're using everything but the last element, so everything to the -1. And then if this is the case, we return true. All right, I hope this works. So for this, what was it? So for this test one, we should get 11,387, So let's hope it works. Let's see if everything's right so far. Hope so. So go here and let's exit this and let's run this. String and int. Oh, silly mistake. Let's leave that open. Yeah. So this is the string. What we want. Remember, we want the length of it. We need the length of it to be greater than that. So let's save that and run it again. Okay, maybe not. 38. Okay, so there must be a problem here. Helper. Yeah. So here, I'm passing in the string, but I remember I need to convert that to an int. Sorry. Cool. So that's what we wanted here, and that's basically it. So remember what the goal was. The goal was to, once we had a working part one, the goal was to minimize the amount of operations or alterations to our current working stuff. So I think that should be I think that in general is a good engineering practice. And then we just try to continue on with the original approach. And the approach was to remove a single element at a time and perform the inverse. And then we move forward with the inverse. And then I think I said I was going to explicitly mention why this, about this strictly part. So at some point though, the reason why it's strictly is because of this. What if this was the case? If we have 15 here, 156, and say this is yeah, that's right. Say this is a 3 here, sure, 4, and this is 156. Just suppose we have that. Well, in this case, let's check everything. The length of this is 3. The length of this is 3. So remember, if I'm supposing if this is equal. If this is equal, that means I can strip it off. If I strip this off, that means I'm left with nothing, and I still have an element remaining. So this would cause an error here because when I convert it to an int, the int of an empty space is going to throw an error. So if you wanted to, you could do, if you wanted to, you could do something like this. So if length of s equals end, and, well, sorry. So if they're the same length, so this target is 3. If they're exactly the same, then we could just simply compare them. We could say, well, we could say, and what is it? And target, if they're the same, so we still have 2 elements remaining. Yeah, I don't think we could do that because again, I think this would throw an error here. Yeah, that's right. So that's why this wouldn't work. So you need to at least have something there. That's right. So this wouldn't work. That's why I add this strictly then, because of this int here, we convert it to an integer. If there's an empty string here, then that means it's not going to work. So if you found this in any way helpful, please like or subscribe. Other than that, have a wonderful day and take care.